Good morning, everyone. Okay, today we are going to review for your exam tomorrow. So for those of you who did the review, please ask any question you want. So are you guys looking for questions? I'm going to do one more problem was about work, the one that we did yesterday. And then I will leave the stage for you. If you guys don't have questions, I will pick up some and I will do that. Okay, so yesterday we've talked about stretching a spring and the work that's done on the spring. And the idea was basically that if this is the spring, that's its equilibrium position. If you stretch the spring from A to B, so you stretch it from here all the way to here, then the work done was the integral from A to B of f of x dx. Now, what is f of x? F of x is the force. Once you are at a point x, if you want to keep pushing it, you need a certain force. So f of x represents this force. And Hooke's law gave us a formula for this force. So the formula for this force is that the force is always a certain constant times the amount of stretch. Okay. Now, with this in mind, unless you guys have any questions, okay, I will unit. Let us remember a little bit the unit just to make sure. Unit of force. As I said yesterday, there are two units of force. Unit of force, foot. Unit of distance, a pound of distance. Foot, give me unit of work, pound foot. And force, Newton. Distance, meter. Unit of work, Newton meter or joule. All right, that's what we did yesterday. And the unit of K, after I left you yesterday, I realized I did something wrong with the unit of K. K, as I said yesterday, it's force over distance. That's what K. So the unit is Newton per meter. So that's the unit of my K. Right? So as I said, I will do number, which one? I will do, let's say, number 27, and I will proceed to the review. So number 27, they give me the following. Calculate the work required to stretch the following spring 0.5 meter from their equilibrium position. So they're going to give us two scenarios. And in both scenarios, the question is find work, stretch 0.5 meter from equilibrium. In the following cases, okay? Scenario number one. Scenario number one is the spring requires 50 Newton to be stretched 0.2 meter from its equilibrium. So in the first scenario, we need to find this work if the spring requires 50 Newton to be 0.2. So we have to definitely read the sentence and analyze it. This is my spring. That's always my equilibrium. And then if I stretch it 0.2 meter, there is a force that I need to be able to hold it stretch. This force is 50 Newton. So that's the force. All right, now we assume Hooke's law. To be able to find the work, I need the force. To be able to find it. The force is K, because we assume Hooke's law hold. Right. I need to find the K to find the formula. This tells me it requires 50 Newton. It means that if I want to stretch it 0.2 and keep it stretched, I need 50 Newton of force. And I use this info to find the force. This tells me K times 0.2 is 50. So that's the simple scenario divided by 0.2. Now 0.2, it means 2 over 10. So this will give me 2,500. I know K, I need my force times the amount of stretching. Okay. Now the work to stretch it 0.5 become a simple work. X dx. And then the rest is a very simple math, half x squared between 0 and 0.5. And then you evaluate the rest. Okay, so that's the scenario number A. That's my first spring. Now we're going to do scenario number 2. So again, the question is to find the work to stretch 0.5, but now this is my scenario. Spring requires spring requires 50 joule of work to be stretched 0.2 meter. Okay, what's the difference between A and B? Quickly. What's the main difference between the two springs in the given?
A, you're given the force, and then B, you're given the work.
Exactly. And how will this change the problem? So here I'm given the work. In the first issue, I'm giving the force. And in both scenario, the question is to find the work needed. So that's the question, to stretch 0.5. So in both question, I need to compute this quantity. That's what I need. So I need the force to be able to do that. Okay, so by Hooke's law, I know that f of x equal k times x, and the goal is find k. Okay, how can I find k in this problem?
You would have to equate 50 to the integral.
Yeah, we have 50 joule of work. So I have the formula for the work. But what is the work? To stretch 0.2. Because as I said yesterday, I cannot use, so I stretch it by 0.2. So what's wrong with, so if I stretch it by 0.2, it means the distance I moved it is 0.2, right? That's the distance. Can I use this formula? Work is force times distance.
No,
Because
the force is not constant.
right, because I have no idea what the force is. So the force is not constant. Using this formula is up. That's the distance, all right? But this is not constant. What is the force? Is it the force at the beginning of the stretching? Is it the force in the middle of the stretching? It's changing. Is it the force at the end of the stretching? We have no idea. So this is totally collapsed. So we have, that's why in this scenario, the work is the integral. So we have to use that. So we know the integral from 0 to 0.2 of kx dx. This is equal to 50. Okay, so we have to be very careful what's given. The rest become, and now we solve for k. So I can factor out the k. I can evaluate my integral. And then I solve the problem. So this would give me k times a half x squared between 0 and 0.2. This is equal to 50. It means a half k times 0.2 square is 50. It means k equal 100 over 0.2 square. Okay, which is, I don't know if you guys have to do the math faster, 0.2 is 2 over 10. So if I do that, so it's going to give me again 2000. All right. Am I right? 10 is 2, and that's going to give me
Yeah,
2,
that's right.
20 is 5. Am I right? Okay. So and finally, the work. The work now become by coincidence the same answer. I don't have to. It will become integral. That's the one they want us to do. Equal. You guys can finish. Okay, so we just have to be careful with actually the given, not to confuse this with the simple formula of force, because this doesn't hold unless I have a constant force, which we will not have in the spring. And when we come back on Monday, when we take over work on Monday, we will not have a constant force as well. Okay. All right. Now I start reviewing your exam. And please, if you have questions, just put them up on chat and I will answer every question you have. Okay. So I see will work not be, oh, definitely. This will be on the test. If you guys go over your review, you have also a bunch of problems with that. But work, there is another piece of work, a part of the work that I will start on Monday, which is, of course, not on the test, but spring is on the test. Okay, please do not confuse. Okay, now with this being said, I will do the review. Let me see. Alan asked me number 3C, so you guys can look them over and ask. So problem number 3C. Okay. Before I do any of the problem, one of the things that always you should remember is the following, especially for the area and the volume and all of it. It's the distance, horizontal versus vertical distance. If I give you 2 points, just any 2 points, and I will give them coordinate, and I'm going to give them, like I'm going to write x0, y0 here, and x1, y1. What's the horizontal distance between those 2 points? We're always going to do that, find horizontal distance. So in this scenario, what's the horizontal distance between those 2 points? I'm listening.
X1 minus x0.
X1 minus x0, is he correct? Always that's from here to here. Horizontal distance is always, that's the x value, is always the left minus the right. That's always the horizontal distance. So always keep this in mind. What's the vertical distance between the 2 points? Vertical distance, always the upper value minus the lower value. Regardless where the point are, it means even if the point are one above the x-axis, one below the x-axis, I don't care really. Always the upper minus the lower, and horizontal distance, the right minus the left. Okay, always keep those in mind whenever you're doing this problem. Okay. So let me look at number 3C. Let's see what is it about. For each of the region below, do the following, sketch it, draw a typical approximating rectangle, write a Riemann sum, set up the integral to find the exact area, and find it. So sometimes I say find it, sometimes I don't, it depends on the problem. And C is the region bounded by x plus y equal to 0, and x equal y squared plus 3y. So let me write the region, x plus y equal to 0, and x equal y squared plus 3. And I need to find the area of the region between them. Now, I don't know how to do anything without a good sketch. So we are going to sketch the graph of this function. Okay. X plus y equal to 0, that's simple. It means y equal minus x. So this is x plus y equal to 0. Okay, so that's easy. Now, x equal y squared plus 3y. This is a little bit harder, but this is basically, let me ask you a question on the side. It's the same idea. If I ask you to sketch y equal x squared plus 3x, you guys know how to sketch that? Quickly. Yes. Anybody else besides Alan know how to sketch that? What's this immediately? Come on, guys. Parabola, up or down? That's a parabola going up. So it looks like that. All right, so we know this piece. Now, I would like a better picture. You can find derivative and keep going. But here I say, okay, if I know where the zeros are, I can graph it. So the zeros are, so if I want to find when y equal to 0, I factor out my x plus 3 equal to 0, x equals 0, x equal minus 3. All right, so if I want to sketch it, so this is minus 3, this is 0, this is going to go like that. Okay, that's y equal x squared plus 3x. Now, if I want to sketch x equal y squared plus 3y, it's actually the same thing. It's a parabola, but it's this parabola, instead of going up and down, it goes right and left. And this parabola is its opening is to the right. And it's nice to know, like I did here, when does it intersect the y-axis? It means when is x equal to 0. So the same thing, y equals 0, y equal minus 3. So y equal to 0 and y equal minus 3, this is my parabola. So it's really the same idea. X equal y squared is a parabola, but that's parabola moving to the right. And then if I find the zeros, I can sketch it very easily. So that's how I will sketch this parabola. So this is minus 3 right here. This is my x, so this is my parabola. It goes like that. Okay, and that's my region. My region is the region bounded by those graphs. So that's really the region I need to find. Okay. So now how shall I find this area? That's an area problem. So be careful, area versus volume. So that's the area. So I'm not rotating, I'm not doing anything. Okay, so to find this area, how do you want me to cover it? Horizontally, vertically, what's really going on? Absolutely, it has to be horizontal, simply because in both scenarios, x is given in terms of y. That's reason number one. The reason number two, that if I take vertical, there is change in the lower curve. Right here, this is the lower curve. Sorry, right here, this is the upper curve. If I take a rectangle here, the upper curve is changing. So if I take vertical, definitely I have to split the region. So we're going to take horizontal. So this is going to be my yi, and this is my typical rectangle. Okay. So to find the area of a typical rectangle, the area is a typical rectangle. This is my little delta y. It's the length times the width. The width is the delta y, the length. Now I give you a minute to tell me what's the length of this rectangle.
Minus y squared plus 3y.
The length is the y value to the right minus, sorry, the x to the right minus the x to the left. That's a horizontal distance. So the x value here minus the x value here in terms of y. So if this is yi, it means this point right here, that's minus yi, because this is the curve x equal minus y. So this is equal minus yi, that's the right curve, minus the value, the left curve. The left curve, you have it. X is given in terms of that. So the left curve is going to be yi squared plus 3yi. That's the link from here to here. So it is the right curve, which is x equal minus y, minus the right curve, which is the right curve minus the left curve, yi squared plus 3y. Now I am done once I set up. I'm not quite done. I still have one thing. So that's minus yi minus yi squared plus 3y. Okay, now to find the total area, the Riemann sum is, so the whole area is almost equal to the sum of the area of those rectangles. That's really where my Riemann sum is. It means the sum of minus yi, that's the length, delta y. Okay, the total area. Now we use the definition of the definite integral, which tells me that when n becomes very large, this is given by the following integral: minus y, that's the length, and then I simplify in a second, but I'm just making sure now that's the length. And I still have a big problem, which is here. How can I find the intersection point? I need upper and lower. So I need the y value here and the y value here. How can I find them very quickly?
You would equate the two equations together.
Yeah, what's equation? So intersection.
Negative y equals y squared plus 3y.
Right. I have to equate the x's. So I will set y squared plus 3y, that's the x from one curve, equal the x from the other curve, which is the minus y. This would give me y squared plus 4y equal to 0. Factor out my y plus 4 equal to 0, y is 0, and y is minus 4. So this is right down here, that's the minus 4, and this is the 0. So to cover this region with rectangle, I have to divide the interval from minus 4 to 0. And that would be minus 4 all the way to 0. Okay, and the rest is simple. Usually when I need to integrate, I try to see, can I simplify the inside? So the inside is minus y squared minus 3y dy. So minus y minus 3y, that's going to give me minus 4y. And then the rest is very basic math. All right? And then you guys finish. Questions before I move on? Anybody? Okay. All right. So this is a typical problem where we definitely have to take those horizontal slices. As I said, first, x here is given in terms of y. It's hard to solve for y in terms of x in this equation. So that's already telling me, you know, you have to keep y as your variable. That's already telling me that. And second, if I take x as variable, I need to split. I need to split into two regions, here and here, because the upper curve is changing.
Professor.
Yes.
So in the question, you told us that to label
Right.
the typical
It means
approximation.
from here to here. That's the length. And that's the width. The width is delta y. The length is the right value minus yi minus the left value, this one. That's what I mean by label. Is it making any sense?
Yes, I see.
Okay, and this is your yi. Your yi is down here. Because the idea is that this is y0, This is y1, y2, y3, and so on. So, and this will become your representative. Area of a typical rectangle is this. That's your Riemann sum, and that's the definite integral.
And can I change the place of 0 and -4?
No,
Does it make it and change?
no, it's from -4 to 0. You mean 0 to -4? It's wrong. Okay, 0 to, you can change them, yes, but then it will be minus. Are you with me?
Yes, I got it.
Yeah, you cannot just change, you will get a negative area. Okay.
Thank you.
So if you guys don't have questions, which is you guys are not writing anything, which is okay, I will, as I said, I will do a few problems on my own from the review, of course. So in number 2, 5A, I will look at it. Number 2, we have, I'm going to ask you two, I just picked 2 problems. There is nothing really deep about them. Let us say I have the integral, doesn't mean I'm going to give them tomorrow. 1 over x squared, so that's the g part, cosine 3 over x dx. Okay, evaluate quickly. How would you do that? Come on. How would you evaluate this integral? How would you do that? Substitution. What's substitution? It has to be a substitution. What's the natural substitution in this problem? The insight. It's really a mess to deal with. We definitely would like to get rid of it and hope for the best. And having 1 over x squared should definitely tell you, 1 over x is the way to go. So I will find the derivative. So this is 3x to the minus 1. It means the derivative is minus 3x to the minus 2, the dx. It means the du is minus 3 over x squared dx. Okay. Now I go back to my integral and do the substitution verbatim. It was equal to cosine 3 over x. That's my cosine of u. Times the 1 over x squared dx. Now, of course, we are smart enough to know that this is almost the same. So 1 over x squared dx, I can pull it up from here by dividing by a third both sides. Give me 1 over x squared dx. And this will give me minus a third du. And now the problem is basically done. Minus a third factored out. That's a constant. Cosine u du minus a third. The sine of u minus a third. The sine of 3 over x plus c. End of the problem. And now you integrate this, you differentiate that, you get exactly what's inside your integral. Once you differentiate, you get that. Okay. Right, I will do one more and then I will pick up 5A, I guess, from before. So let me do number L. I have to find the antiderivative of this function. Okay, and how shall I go by it? And I give you a hint, split the numerator first. What do I mean by splitting the numerator?
You can split up the integral, so you could do the integral of 1 over 1 plus x squared. plus
Mhm.
the integral of x over 1 plus x squared.
Right. I told you split the numerator because we can split the numerator. We cannot split denominator. That's absolutely wrong. But numerator could be split. Then I'll be left with x over 1 plus x squared dx. Okay, I had to give you the hint because this is, you will not think about doing that. All right, now every piece by itself. What's the antiderivative of this function? That's arctangent, absolutely correct. That's arctangent x. Plus, what about this one? How can I find the antiderivative of this function? Again, quickly. That has to be u substitution. Okay, so this is, I'm going to isolate it totally by itself because I don't know what's antiderivative, but I know how to do it. I have to put u substitution, 1 plus x squared du is to x dx. And then this would give me the following. X dx is a half du. And this is 1 over u times a half d. Now a half is a constant. I can pull it up. I will have antiderivative of 1 over u du. It means a half ln of u, which is plus of c, but I will take care of that there, which is a half ln of the absolute value of 1 plus x squared. Okay. Now a simple question. Can I get rid of the absolute value here? Would it be correct? No? Yes? We have to make up our mind? Yes, because. Why yes? Because 1 plus x squared is always positive. So you actually really don't need, right? No matter what the x value is, it's always positive. So we basically, thanks Julian, we have to take it positive. So finally, I will have this is a half ln of 1 plus x squared plus my constant c. Okay, so it's not really a hard problem. It's just a matter of splitting. And this is a type that we will deal with a lot when we start working with integration. Okay, so review all your substitution and then I go back to your question. If I recall, David asked me 5a and then Sami number 6. So I will do 5a first. Okay. So let R be the region bounded by the graph of y equal x cubed. The line x equal to 1 and the x-axis. For each of the problems below, draw your slice labeled clearly and then set up the integral to find the volume of the solid obtained by revolving the region about the x-axis. First, about the x-axis. That is your classmate question, and I want you to do it both ways, disk and washer, and then this probably it's simpler in both ways. That's why I want you to do it both ways. So this is my graph because I cannot think without it. Y equal x cubed. So we should remember y equal x cubed is like in S, go like that. X equal to 1. X equal to 1 and the x-axis. So this is the region I am interested in. Let's find the intersection point immediately because we know that we need them. This is y equal x cubed. It means this point here, if this is 1, I plug in the 1 here, I get a 1. So this point is 1. All right, first we want to do it using the washer or the disc. So here the slices are perpendicular. So the axis of rotation is that. We have to take slices perpendicular to the axis of rotation. So this is my typical slice. That's my typical slice, and this is my XI. Okay. And now my first question is, if I rotate this, what do I get? In this scenario, of course, when we rotate, because the slice is touching the axis of rotation, there is no hole. So rotate, we are going to get a disc. So rotate slice, get a disc. Will give me a disc. Now we need the volume of the disc. It means we need the radius and we need the height of the disc. So the radius is from here to here. That's the radius. And if this is xi, it means this vertical distance is nothing more than the value of the function here. That's my radius. The height, when I'm going to rotate that, the delta x would be the height. Okay, this is the labeling I am after. So here, radius is xi cube, height is the delta x. Volume of typical disc is pi times the radius square times the height. Okay, so now the total volume, we add the little volume. To add them, I have to divide the interval between 0 and 1 into a rectangle and split each. So I will have integral from 0 to 1, pi times x cubed square dx. And now I simplify and I proceed. Pi is a constant. X cubed square, it means x, we multiply the power dx. And the rest is simple. We should get pi over 7. Okay. Now we do that in the shell method because I'm asking you to do it in both. Any questions, please ask. So the shell. So this is my region. Okay. My rotation is the x-axis. The shell, it means I need to take those slices which are parallel to the axis of rotation. So immediately now, y is becoming my variable. And I'm going to take the slice. Okay, that's my slice. And when I rotate this slice, only about the x-axis, so there is not much into it, I'm going to get my shell. Okay, for a shell, we need 3 things to be able to figure out everything. We need the radius, we need the height, and we need the thickness of my shell. Radius, height, thickness. All right. So first the radius is from where to where and labeled. What's the radius of the shell? Very quickly put it. Please, I want all of you to put it, not only the same student all the time. What is the radius of the shell?
Isn't it just y?
It's y, exactly, because it is from the rectangle to the axis of rotation. This is the radius. YR. So the radius is YR. What is the height of the shell? So the radius is here, from here to here, the base of the rectangle to the axis of rotation. What is the height of the shell?
1 minus x.
What's your problem? Why I said What's your variable?
Or 1 minus f of y.
Right, what's f of y? How are we gonna get that? the graph was y equal x cubed. Okay, so we need the x value here, which is a 1 in terms of y, minus I want the x in terms of y. So if y equal x cubed, it means x is the cubic root of y. Okay, so for you, what it means? For you, it means that if this is your yi, this point here is basically the cubic root of yi. That's really what it is. So you're finding the distance from here to here. So you need the x value here, which is 1, minus the cubic root of yi. So the height is 1 minus the cubic root of yi. The thickness is the delta y. So everything has to be expressed in terms of y. Now, at this stage, volume of a typical shell almost equal to 2 pi times the radius times the height times the thickness. So the total volume is, we figured out this point. This is the 0.11. It means right here it's a 1. So integral from 0 to 1 of 2 pi y, 1 minus cubic root of y, it means y to the power a third dy. Okay. So that will be the integral. Now 2 pi is a constant. I will just start the integration. Integral from 0 to 1. And the only way to integrate this is basically to distribute. So this would give me y minus y times y to the third is y to the power 1 plus a third for third dy. And then the rest, I think you can finish the rest. Okay. So always be very careful when you take horizontal slices, means y will become your variable and everything has to be expressed in terms of y. There is no x and y within the same integral. No way. There is one variable, either the x across or the y across. It's the delta y which will tell you. So if you have a delta y, y will be your variable. Okay, any questions about that? All right, now Sami, I think.
Professor?
Yes.
Actually, I have a question for this one. In the question says label it clearly. So like, is it enough for us to show just the delta?
No, label clearly. It means I want, in this scenario, when it's a shell, what do you label? You label the radius clearly. I want to know what is the radius from here to here. That's the radius. The height. What is the height? That's the height. So the thickness is delta y. That's the delta y. That's what I mean by that. I want to know exactly, do you know what's the inner is? Do you, the height, the radius? Now, if I give you a washer, what do you think I want you to, let me say I take the same region, suppose I take this region, and I rotate it around the y-axis, and I want you to use the washer's method. So if I use the washer method, it means I have to take those slices. Okay, so y-axis, washer. Okay, so in this problem, do you want us to find exact? I will be very clear, Krish. Okay, I will be very clear. Okay, if I want you to evaluate or not. All right, so in this scenario, if I want you to label, what do I mean? If there is a washer, I want you to tell me the inner. Where is the inner? I want you to tell me the outer. So in this problem, the inner would be from here to here. That's your inner radius. Equal. That's what I mean. I will get back to you. The outer is from here to here. So this is basically my yi. The outer is from here all the way to here. That's my outer radius, which is in this case, for example, 1. Okay. The inner in this case is going to be the cubic root of yi. And delta y is the height of the washer. That's the labeling I am expecting.
I
Okay.
see, thank you.
All right, that's what I want, because I want to know the student, do they know what the inner is? Do they know what the outer is? Do they know what I'm talking about? That's really what I want. All right,
Yes, thank you.
very good. Now, what other question you guys asked for the last 5 minutes? If my memory is right, I saw number 6 somewhere, right? Did anybody
Yes,
ask 6? Okay, so I look at number 6, and then I wish you good luck. Number 6. It's the same ideas. Let R be the region bounded by y equal x squared plus 2. And y equal x plus 4. And the y-axis. And if my memory is right, yesterday one of your classmates sent me an email, and I should have added in the first quadrant. Made me realize that I should put first quadrant. So the new copies, I uploaded a new copy with first quadrant in. And the question is the same stuff. X-axis, the line y equal to 6, and the y-axis, okay? So I will do one of them, not all of them. So first, the region. Y equal x squared plus 2, that's a parabola. Since I'm only into, that's the parabola like this. The first quadrant will give me this piece. Y equal x plus 4, that's straight line. 4 is the intercept. So that's really the piece that I am interested in, okay? Now I definitely, immediately, I need the intersection, we know that. So I can set the x is equal, so intersection, x squared plus 2 equal x plus 4. This will give me x squared minus x minus 2 equal to 0. I factor out, and I will have 1 and 2 minus plus x. Give me x equal minus 1, x equal to 2. So x equal to 2. And if to make sure I'm doing it right, I plug in the 2 in this equation, I get a 6. I plug in a 2 in here, I get a 6. My computation is correct. All right, so that's the region. And now I'm going to rotate it around several axes. I'll pick 2i because it's kind of different. And then I'll talk about I. 2i is rotate around the line y equal to 6. Okay, so this is my axis of rotation. Y equal to 6, not x. Be very careful if I ask you those questions tomorrow. So this is my axis of rotation. Okay, now I'll ask you, what do you want to use? The shell method, it means parallel to the axis of rotation, or the washer method, which means perpendicular. Okay, I really would like, it's like 2 more minutes to finish that. The washer, the shell. All right. I will tell you what's the problem with the shell. Shell, it means parallel to the axis of rotation. All right. If I take the shell method, what do you think is going to be the problem? Watch carefully. I take my shell, means I take my rectangle here, versus I take my rectangle here. What do you think is the problem? Quickly. What's going to change? If I take my rectangle here and I rotate it, that's going to be the height. If I take my rectangle here, the height is going to change. So taking the shell in this problem, you can do it. I'm not saying you can't, but then you will have to split the region because the height will change depending on the region I take. So we're going to do it using the washers method. Washers, it means slices perpendicular to the axis of rotation. It means those horizontal slices. Means in this case, I need to fix my xi is fixed. All right. Washer, so I'm going to rotate this. around y equal to 6. That's my rotation. Around y equal to 6. That's really my rotation. So for the washer, I need the inner radius, I need the outer radius, and I need the height. This is my washer. The height is from here to here. That's the height. It's my delta x. What's my inner? What's my outer? Very quickly so we can finish. What is the inner radius? Look at the picture, as I said in class last time. Okay, so what's the inner? Okay, on the picture, who can describe the inner in words? Who can describe the inner radius in words from where to where? I think you can do it on the picture.
Is it 6 minus x plus 4?
What? In words, it means don't tell me the formula. It's from where to where?
From x equals to 6 to
Why
y
equal to 6? Y equal to 6 to the line. Right? Is it correct? That's the inner. What's the formula for the inner? So this is xi. What's the formula for the inner? Anybody?
top minus the bottom.
Exactly. Top minus the bottom. What's the top?
6
6. What's the bottom? If this is
x plus 4.
Right. Xi plus 4. Absolutely correct. 6 minus that. All right. It's the top. It's the 6. It's the top value of y minus the lower value. That's the inner radius. What's the outer radius, all of you? What is the outer radius? On the picture, the outer radius is from y equal to 6 to the bottom curve, to right here. That's, again, a vertical distance. What's this vertical distance equal to? The top value minus the lower value. Now, you guys, the top value is 6 minus the lower value means this is, if this is xi, it means this is the lower value. It means this right here is the xi square plus 2. That's really, so it's the distance from here to here. That's the distance from here to here. It's the top value minus the lower value, which is xi square plus 2. And then the rest is simple. This is, I simplify it, give me minus xi, 6 minus 4, it's a 2. And this 6 minus I, 6 minus 2, which gives me a 4. And then you proceed from there. All right? Okay, the best of luck for tomorrow. Please go over the review. I have office hours from 10 to 11 today. Show up. And if you have any questions, you can email me. All right? Anybody who's, the class is over. Anybody who wants to have any question can email.